No. So today now we will read how to manage the program core itself. So in previous part I discussed about the concept of heat, and also I discussed about in this heat thought there are two phases. One phase is to create a heat, and second phase is to delete the root element from the heat. So today now we will write a program how to create a heat, and a heat it is stored in a one-dimensional array, and as heat is a binary key, therefore every node except root node, every node has parent, and except the nodes, all other nodes having the child. And from one-dimensional array, they can understand which position is supposed for a particular position. So for the I, suppose I think that so for use of if a node is at index I, then which node is its parent's code, that we can find out. That is I by 2. Or if I is a node, then what are the index of the children? So let children will be as it is a binary tree, it can have across 2 children. So if the next children index of the next children will be twice 2 into I, twice I, and the index of the right children will be 2i plus 1. In this way, we can find the parents and child relationship for every element in that array. So how does heapsort work? First of all, an array will be given, and we will think of it as it in a binary tree. Now they will change this binary tree to heap structure. So heap structure means if we consider any subtree, then root node of this tree will be, if it is massive, root node of every subtree will have the z value, then all of its children. And if it is a mean heap, then for every subtree, the root count will be lower than both of its children. So we want array to be sorted in ascending order, and in that case we are using the maxsub. Maxsub means what? Maxsub means for every subtree the root node has the highest highest value among both of its children. So how to write a program for creation of heap? So we will go to the program editor. So 30 is here on C program. Next, city searching max gedit heap.c. So I will include the stdio.h header file. Next part is include stdlib.h, another header file. And for this particular example, we are taking the array of 10 elements, and we can change maybe 10 elements. You can change the size of the array just by giving the different value to a particular constant, which is indicating the size of the array. So for that, we are declaring the constant here, which is array size. And for this particular example, we are using an array of size 10. Next, I will introduce the array. So I will initialize it, the values. Now, is the array size first? You see what array size 10 means the index value of this element of the array will start from 0 and will go to 9. But for our program purposes, we will reserve the 0th index, which can be any arbitrary in value, which is not a element of this array. So for arbitrary 0, I'm placing 1000 here, and as I told you, that array size will be there will be 10 elements in that array. So I need array size 1 more, because for 1000, 0th index is not used. So to store 10 elements, we need 10 more locations, so array size will be 11. Now what are the values that we are storing in an array? Actually, to construct the heap, we will not do anything in the heap structure here, but we will change the position of the array element and replacing that array elements in their order, so that will represent the heap. So array elements are suppose 11, 2, 9, 13, 57, 25, 17, 1, 90, and 3. 1, 2, 3, 4, 5, 6, 7, 8, 10 elements of there. Next, so I will create heap, and for that I will use a function called create heap, and so this function is declared here. Then I'm designing the function create heap. So in this create heap, how to create a heap? Now for creating a heap, so we'll start from the highest index value, and we will go up to index value of 1. That is the array elements which we want to sort. That is from index 1 to index 10. So for every index value, I told you that if a parent is I location, then there will be at most 2 children, and suppose a left and right choice, the left hand will be at location twice of I, and the right choice will be twice I plus 1. So for example, in this list, but how can I understand whether a node is even? So how to get its parent value? Suppose node is at ith index value, then its parent will be I by 2. Now consider this particular array whose size is 11. So the highest index value will be 10. So what will be the value of this 10th element, which is at 10 index? Now it will be 10 by 2, which is equals to 5. So for this particular example, if the highest index value is 10, is the element is 3, then the parent of this node will be at location 5. That is 1, 2, 3. That is 57 will be its parent. Now and then consider the next index, that is index 9, and at index 9 the element is stored is 90. So if we divide 9 by 2, and we take the integer part only, so the value will be 4. So which node is the parent of node 90? Now fourth index node, fourth index array element would be the parent of 90, with just 1 is 2, that is 30. Similarly, if we consider the next array index, which is equals to 1, that is, if index is what? Index is 8. And if we divide this 8 by 2, it will be 4. 4 means the parent node will be 3. So we can say the 1 and 90, they are 2 children of node, which is at location 4, and the value of it is 30. So 13 has 2 children, 1 and 90. 1 is left children and 90 is right children. But if we consider the node 3, which is at the highest index of the array, that means 10. So node its parent is 57. So 57 has only one child, which is known 3. So how can we understand? So in this way, we can understand that which node is parent of which node, or who are the children of the parent node. Now, for this particular example, we can see that 57 has only one child, which is 3, but 13 has 2 children, 1 and 19. So how to get to know whether the parent has only one children or parent has 2 children. So how to know that? So for that we use technique. What does, suppose left children value, the index of the left children is 2D left variable. So, and the index of the right child is 2D right variable. So I will create 2 variables in left, comma, right, which will left variable will store the index of the left child, and right variable will store the index of the right child. And suppose for node 1 and 90, the value of left will be 8, and for 90, and the value of right will be 9. And who is the parent node? The parent node is int parent, and if we divide left by 2 or right by 2, we will get the same parent. If a parent has 2 children, that means if we divide left by 2 and also right by 2 and taking only the integer part, we will get the same value as parents. So that means that parent has both of these are children of those parents. So in that case, we are using parent. Now, okay. Now, this is the variable. Now, what we will do to create an input, we start from the highest array index, and we will check. We will find its parent, and if parent is less than, if value of parent is less than of its children, then we will swap parent and children. And what happens when they have both 2 children? So in the 2 children, which child has the higher value, that will be, and if the parent of both nodes are less than any, suppose 2 children and only 1 child, suppose what is 1 and 90 node, the parent children is 13. Now 13 is greater than 1, but 13 is less than 90. So we will swap the value between 30 and 90. But suppose it may happen that 13, that the parent has, the both of the children has a higher value than the parent. Then which children, parent will be swapped with which children? The child which has a higher value. Parent will be swapped with that higher value children. So in this way, if what is the reason behind this technique? Technique is to always for any subtree, always the root node will have the highest value than either of its children, either or both of its children. So in this way we will do it. So now, so how can I know whether a parent has 1 child as 2 child? If the left by 2 and right by 2 is equals, we will take left and right, adjacent, and if their value is same, that means they're children of the same parent. But if their value is different, that means the parent has only 1 child. Okay, and their parents are different. They are children of 2 different parents. If their length by 2 is not equals to right by 2. So initially, what I will assign to it? So initially, I will assign right equals to what the maximum index. I will start from maximum highest index value of the array. So right value of right would be initially array size -1, and left as minus 1 and left equals to right minus 1. Right minus 1 and so now I will check whether they are children of the same parent. So suppose initially the right will be 10 and left will be 9. Now I will do operation if left by 2, if left by 2 equals to right by 2, ROGST by 2. That means their children of the same parent. And so how to indicate whether that the array is the sizes as much that only the last child whether it has both of the last child is there on the third and the before just previous element whether they have the same parent or not. So how to understand it, and using a flag here when the array size is such that the last two elements are the children of the same parent, then we will use flag equals to 1 to indicate that, because that will be required to indicate that. So in flag, our variable is initialized else. Else means if let 2 is not equals to right by 2, we are initializing the flag value equals to 0. So, okay, next part will be false work. After this,